right, in lesson 6.5, excuse me, this is not 6.6, this is 6.5. In lesson 6.5, we're going to talk about linear inequalities, and we're going to be doing some graphing and some solving and some checking. And then the next section, 6.6, we're going to be solving systems of linear inequalities, all right? So first I want to begin by comparing each of these, okay? The first one here, that I'm highlighting right now in yellow, this is a linear equation. So what makes that a linear equation? Yeah, Will.
The exponent is 1.
The exponent is 1, true. What else makes it a linear equation? Yeah, Daniel. The equal sign makes it an equation, okay? So notice that. That's different than what I'm going to highlight over here in blue. All right? How does that read in blue? How do you read that? Y is less than a number plus 1. Very good, okay. And then how about this one over here that I'm highlighting in pink? How does this one read? Y is greater than a number plus 1, okay? So the yellow one, the first one, that's a linear equation. The second two, those are linear inequalities. See the difference between the two? Okay, so we have to have the language down. So linear equations versus linear inequalities. Okay, so go over to Desmos. Now you guys all have those. You should have them up right now. And we're going to type in a linear equation. So it should be just y equals, we have x and then plus 1. All right? And we should all see that we just get this line over here. It's no big deal. So I'll close that down. It's just a linear function, so we would expect to get a line, and the slope is 1, and the intercept is 1, and it's no big deal. Okay, now, how do we compare that to y? And now the less than button, they actually have them right down here. Notice that these four over here in the screen. They have less than, they have greater than, they have less than or equal to, and they have greater than or equal to. So let's go ahead and just push the less than, and then we want x plus 1. Okay, so notice that it's the same exact line, but my screen is very different, and we can compare the two. If I just turn this off, notice that if I have a line, then all I have is a line. But if I have an inequality, notice I have a region here, okay? So this region that's shaded is the region that makes the inequality true. So give me any point that would fall in this region. Give me a point, and we'll test it out to see it. 2, 1, okay? Notice that this point lands right here in the region, okay? That means that this point is a solution to the inequality. If I plug x is 2 and y is 1, I'll get 1 is less than 3. That's a true statement. Therefore, it's a solution to the inequality. So this begs the question, how many solutions are there to this particular inequality here? There's an infinite amount. We could be here all day putting points on the plane here, right? If I zoom out, look, the region just stays the same no matter what I do, okay? Now, give me a location of a point that would not be a solution to this system. Just shout one out. Negative 5, comma 0. Let's put that point on there. Notice this point is over here. It's outside the region, okay? If it's outside the region, then it doesn't fall within the boundary, and therefore is not a solution to the inequality, okay? Now, I'll turn these off really quickly here, okay? Now, this line right here of the inequality, this is called the boundary line, all right? The inequality is called the boundary line, and the shaded region is called the boundary, okay? So we have the boundary line and the boundary, okay? Now, the other one that we had was, y was, if I go back to my lesson here, we had y was greater than x plus 1. What do you imagine that's going to look like?
It's going to be shaded in the other direction.
Shaded in the other direction. Y is greater than x plus 1. So move it up like that. So notice that my orange one is shaded above my boundary, right? And so it should look something like that. So you can get a good idea of what inequalities are doing by looking at their graph. And the same thing works for the orange region. I could pick a point that's part of it, and I could not pick a point that's part of it, okay? All right, so let's erase all of these here now for a second. Okay, erase that, okay? Now type for me this. Type for me, did you see, was it this one? Yes, this is how they do it. Okay, so let me go to projector mode here to make it a little bit more obvious. Okay, so take a look at this line here. y is less than x plus 1, and then take a look at this line over here. I'll do y is less than or equal to x, and then I'll just say minus 2. Okay, do that. Okay, so take a look at the line, the black line here. I'll turn this off for a second here. What do you notice about this black line here versus this blue line here for the boundary line? Yeah, one's dotted and one's not. What does that mean? Yeah, so this one over here, my blue one, this is just strictly less than. And then this one over here, this is less than or equal to. So the boundary line in one of these inequalities is part of the solution, and the boundary line in one of these is not part of the solution. So which one do you think is which? Yes, less than or equal to, the boundary line is part of the solution. Strictly less than, the boundary line is not part of the solution, okay? So as an example, if I gave you this point right here, if I gave you the point 0, 1 and turned it on, okay? Is that point part of the solution or not? No, it is not, because it is on the boundary line. The boundary line is not part of the solution. Even if you check and see, if I plug in x is 0 and I plug in y is 1 less than 1? No, it's a false statement, okay? So it is not part of the boundary line. Okay, so let's head back over to our notes here, right? So when we have an equation, we're going to have, something that looks like this, just an equation. When I have an inequality, okay, so I'll go up to 1, I go have a slope of 1, and I want strictly less than that. Notice I have a dashed line, and I want everything that is less than that, so I shade to the or everything that's lower than that. If I have something that's y is greater than x plus 1, well, again, I would have a boundary line that's been dashed, and I want everything that's greater than that. I want everything that's above that line, okay? Now, if I have y is less than or equal to x plus 1, what did we notice? Well, the boundary line is what type of a line? It's a full line. It's solid, okay? It's a solid line, and my boundary region is still below here. All right? And then if the last one, if I had y was greater than or equal to x plus 1, what we realized was that it is a solid line, right? But I want everything above that line there. So this is what we're talking about when we're speaking about linear inequality. Okay, here we go. X is greater than or equal to 2 and y is less than 5. We're going to practice graphing inequalities. So we're going to graph these by hand, and then we're going to check Desmos, make sure we did it right. Okay. So I have a coordinate plane. This is my x-axis, this is my y-axis. I want x is greater than or equal to 2. How do I graph the boundary line? Would this be a vertical line or a horizontal line?
Vertical.
This would be vertical, located at x is 2, right? So if I just go over to where x is 2, and I would draw I would draw a solid line. Why would I draw a solid line here? Because it's greater than or equal to. Okay, now which direction do I shade? I shade to the right, because I want everything that is greater than or equal to a value of x equaling 2. And yes, you actually have to shade to the right. Some people use the side of their pencil, they use a highlighter. So if we check this answer over here, if we turn everything else off, okay, and we go over here, let's turn this off as well. We wanted this. We wanted x was greater than, so I'll make sure I put my thing up here. We wanted greater than or equal to the number 2. There we go. So this graph here pretty much matches exactly what I have over there, and that's how you would graph it. Does that make sense?
Yes.
So there's the graph, and there's that there. Okay, good. Let's do y is less than 5. Okay, so again, I would make an xy coordinate plane. Now, y is less than 5. We treat it as if it was the equation y equals 5. So I go up to 5. 1, 2, 3, 4, 5. I would draw a dashed line here. Why would my line be dashed for this case?
Because
It's just strictly less than. So which direction should I shade?
If it's less than, you should shade to the bottom.
I should shade all this stuff on the bottom here. Everything below the bottom, all the way down to infinity. So we can check to make sure that we're doing it right by plunging in y is less than, just strictly less than for the number 5. And you'll see that the line there is indeed dashed. When you zoom in a little bit more, you can kind of see that's a little bit dashed. And then we zoom out all the way. So that graph looks exactly like what we've graphed here. Okay, here we go. Let's graph this linear inequality. I've got 24x plus 12y is less than or equal to 420. What form of a line is that in? Is it in slope-intercept? Is it in point slope? Or is it in standard? It's in standard. Okay, so standard form is really, really nice in helping us graph what? Intercepts. Yeah, very good. Helping us graph the intercepts. So let's find the x and the y intercepts. If I want the x-intercept, what do I always do to find the x-intercept? Let y be 0. So I would have 24x is less than or equal to 420. Dividing by 24, x is equal to what? Who's got that? 420 divided by 24. Who's got it? 17.5. All right, there it is. So that's my x-intercept. How do I get the y-intercept? Let x be 0. So I would have 12y is strictly less than or equal to 420. Dividing by 12. What do I get for that? Y is equal to what? 35, right? Yeah, 35. Okay, good. So now that I have my x and my y intercepts here, I can go ahead and make a graph. And it seems to me like I'm going to count by, I'm going to call that 5, I'm going to call that 10, I'm going to call that 15, I'm going to call that 20. Same thing. 5, 10, 15, 20. Whoops, I better squeeze down a little bit here. 20, 25, 30, and then 35. Okay, so I know one of the x-intercepts is, the y-intercept is at 35. I know that the x-intercept is at 17.5, so I'm pretty much right down there. And I want less than or equal to. So is my line going to be solid or is it going to be dashed?
Solid.
It's going to be solid. So I'm going to connect those two lines with a solid line like that. And then I want everything that's to the left of this line right here. Okay, so we're going to make sure that we did this correct.
So on the test, do we have to on the test, are we allowed to just make lines, or we actually have to use
You would make the lines.
just
So
like
24x, yeah, just like we did. 12y is the shading part.
Yeah. Do you have to shade with the, like a highlighter or something?
Yeah, or the side of your pencil, whatever you got, okay? All right, kind of hard to tell if I did this right, so I think I need to zoom out a little bit. So look, I'm going to zoom out, and I'm going to see that this point right here, if I click on it, is 0.35, and if I click on this point, 17.5, 0. So I would say that their graph and our graph is pretty darn close to being the same thing. Okay, I've given you 2 points, 3, 1, and 1, -4. I would like you to graph the inequality, and I would like you to graph both points, and I'd like you to tell me whether or not each of those points is a solution to the inequality. Okay, let's talk about this together, and here we go. So you should be able to graph this by hand. It is a line, and it's in slope-intercept form, so it's pretty simple to figure out. So we've done this before. We'll go down to -5, so it should be 1, 2, 3, 4, 5, okay? And then from here, what's the slope of the line? 2. So I go up 2 and I go over to 1, okay? Now, is my line solid or is my line dashed? My line is solid. Why is my line solid? Because it's or equal to, right? Okay, so it should look something like that. Now, it says greater than this, okay? How do I check to see which side of the line do I shade? Do I shade to the left or shade to the right? Which side's the top side? It's hard to tell which side the top side is. So here's a trick that you can do very simply. Okay? Yeah. Just plug the origin in. Is 0 greater than or equal to -5? True or false? True. 0 is bigger than -5. That's true. So that means that we are shading which region? We're shading where 0, 0 actually is. This is a true statement. Okay, so Bella, did you see that? What happened with yours? Okay, good. Now that my beautiful shading is here, then I'm going to plot these points in pink. 3, 1. So go 1, 2, 3, 1. That's that point there. And then 1, negative 4. 1, and 1, 2, 3, and 4. This point here. Now, because my line was a little bit messed up, I'm going to go ahead and use this technology to make sure that I'm doing this correctly. Okay? I think it was too. So I'm going to do, I think it actually is. So y is, it should be greater than or equal to, right? 2x minus 5. Okay, so there's my purple line, and then I had 2 points, right? The first point was 3, 1, and the other point was 1, negative 4, and let's take a look at these points now. Okay, here we go. Now it's a little bit better. Let me zoom in and see what the deal is. Okay, so this point is on the line.
Oh my god.
I clicked on.
Okay, so you guys, is 1, negative 4 a part of the solution or not? Evan, what do you think? Okay, paying attention. Okay, is 1, negative 4 on a part of the solution or not? No, why not? You're right. How come?
Because like it's outside.
Falls outside of the shaded region. Absolutely